This evening I want to talk to you about Amazon's simple workflow, and I want to sort of evaluate and let you guys decide whether you think it's ugly duckling or beautiful swan. So my name's Warren, I'm the lead developer at Radify. I'm based in Cardiff, but we're actually all over the place. We're a completely remote company. There's no real headquarters except for what it says on the letterhead. So if you've got any questions, or come chat to me afterwards, or you can email me, warren@radify.io, and you can find out more about our organisation at radify.io. So I'm going to be talking about what simple workflow is, how it works, give a little introduction. Then I'm going to be doing a case study on how it's benefited us and the kind of software that we're able to deliver to our clients. And then I'm going to be talking about some open source software that fell out of our recent work with simple workflow. So simple workflow is essentially I don't want to say a framework because it's a lot more than that, but it's a whole set of solutions for building a distributed workflows. So it gives you a bunch of primitives to handle task scheduling, managing tricky things that are typically quite tricky, like concurrency and one task being dependent on the result of another task. And that allows it to take care of the things that are usually quite difficult for us, like passing messages, locking certain resources that may be shared by multiple processes, and state management as well. When you're trying to build distributed systems, really it doesn't even have to be a distributed system. These are all typically quite difficult things to work on, and it forces you as a programmer to focus on those things more than you should, and you end up focusing on those, the glue that holds everything together, rather than the thing that you're actually trying to build. So SWF gives you a nice way around that. And so what SWF allows you to do is to break down whatever it is you're trying to achieve into two different concepts, the concept of deciders and activities. And so those decisions and those activities are the heart of your application that you build on SWF, and that's typically called a workflow, that combination. And then once you've got that workflow configured, you'll usually want to send some input data into that workflow, let it process, let it chug along, and then you'll get some kind of output at the end of it. And that applying input to a workflow is called a workflow execution. And so one half of these programs that you write in SWF are called deciders. And so the best way I've found to think about what a decider how it should operate is to think of it just like a software, program code version of a flowchart. And so that flowchart defines the order in which the different processes in the application are, what order they're executed in, and how output from certain processes is passed as input to other processes, and conditional operations and concurrency as well. And typically what you'll find, not typically, always, there is one decider in each workflow, and that is the flowchart. So, and those things, because they're not actually doing any processing, they should be very cheap to run. You don't want your decider to be waiting on some I/O or some CPU intensive operation. So I'm going to come up with this somewhat contrived example for the purposes of this part of the talk. We're going to build the world's first microservice distributed UC first function, which is uppercase the first character in a string. So obviously we can do that really easily, but we're going to make it way more complicated than it needs to be. So we want to take some kind of input string and we want to output it to something else. So at the start of this workflow, we're going to execute two processes in parallel. We're going to get the first character in this string, convert that to uppercase, and then we're going to get the rest of the characters in that string and convert them to lowercase. And then once those two operations have completed, we're going to concatenate the results together, and that will be the end of the workflow, and that will give us our resulting string. So that's our workflow, or that's our decision anyway, flowchart. So you can see there that the first two upper, rest to lower, and those concatenate operations are what we're going to implement in our activities, which are the other part of an SWF program. So they're the real meat of any application. It's where the real processing takes place. And activities can be expensive. In the case of the stuff that we worked on at Radify for one of our clients, which I'll show you later, or as cheap as necessary, as in the case that I'm concocting here. So I've got this sort of TypeScript-ish looking pseudocode to give you an idea of what each of these little activities are going to look like. So you can see our first to upper function, our activity is just going to take that input string, take the first character and convert it to uppercase and return it. Rest to lower does something similar. It just gets the rest of the string and converts that to lowercase. And then our concatenate function just takes each of those parts that the two other activities returned, and then it's just going to join them together. And so program code isn't the only kind of activities that you can have in a SWF workflow. Brilliant, I've got no connectivity here, but those pictures don't really matter. So there are some other primitives that SWF supports, like timers, which allow you to just make your workflow wait for a certain amount of time and then continue processing. Signals, which are they've really been really useful for us. They allow you to just have any kind of arbitrary input into a workflow. So that might be quite useful for if you want a workflow to wait until some external event takes place, or maybe some user input is provided or something like that. So your workflow will just wait until a message has been provided. And then that message can also be passed as additional input later on in the program. And it's also possible to execute other workflows as well. And you can wait for them to complete, and that's really nice. And you can also, have recursion and things like that. Probably would want to avoid recursion in this case, but it just makes it a really nice way. If you've got this enormous, complicated workflow, it's a really nice way to decompose everything and make it a lot easier to understand and maintain. So SWF's got some really nice features in it, but there's a couple of rough edges, and I think this is the reason why it's perhaps not that well understood or that well used. It's the console interface on it is quite dated. You can tell, I don't know, it depends how much time you spend in the AWS console, but you can certainly see that there are different generations of UI design and things like that in there. Some, like certain aspects of it, like the EC2 part of the console, are obviously really nice and modern. You can do things like the UI state is nicely kept in the URL at the top, so if you force refresh the whole page, you know that you're going to get back to where you were before. 9 times out of 10, when I've used an SWF console, if I have to refresh the page or if my session times out, when I relog in and it reloads, I get a 400 error. It's just, the console is really bad. They're sort of the language bindings, SDKs, are kind of limited. The sort of off-the-shelf one that Amazon recommend for building big applications in SWF is the Flow framework, which is Java and Ruby only, which is fine if you use those languages, but for us, we don't use those, so it was a really limiting factor for us, and I'm sure for many others as well. And we also make extensive use of CloudWatch metrics for triggering things like auto-scaling operations. And it would have been really nice to be able to, if we could get some kind of CloudFront metric which counts the number of workflow executions that are currently in progress, it would have allowed us to scale the number of workers that we've got active at one time so that we can work through big queues in a much shorter time. But there's no metric built in that supports that, unfortunately. And also, it's kind of in its own little world. A lot of the other services on AWS, they're all nicely integrated. You've got things like S3 bucket events, and they can fire off a Lambda function or send a message to an SNS topic, all these kinds of things. But SWF is kind of on its own. It doesn't. You can't trigger an SWF execution from an SNS topic or an S3 event. And you can't notify an SNS topic when a workflow is completed or things like that. So it's kind of disappointing in that regard. And what would have been really nice, would it be possible to implement your decider as a Lambda function, which then means you don't have to have some process just hanging around constantly trying to figure out how workflows should be executed. So it's it's great for if you really know that you need to build some complicated process and you don't want to spend your time building the glue to hold it all together, then SWF is excellent, but it has got some pitfalls, so you need to, and there's probably more than this as well, but these were the ones that really stuck out in my mind when we evaluated it, so definitely be aware of them. So for the next part of the talk, I just want to give a brief case study of how we used SWF to solve a problem that we had with our number one client. So I want to talk to you about the Pixwell platform, which I don't know if you've ever watched any of my esteemed colleague Gavin's talks. He's talked about how we manage the infrastructure for this client before, so you may be familiar with it already. So the Pixwell platform is essentially a digital asset management platform which is used by big Hollywood studios like Paramount and Sony, and it's a way for them to catalogue, manage, distribute sort of marketing material for feature films. So you can see here that so essentially when you first log into the platform, you've got all of the projects that a user can see. So you can see there that they're all big budget feature films. And then for any given project, there are then potentially hundreds of different assets, and these are usually things like trailer A, trailer B, trailer C, really dry, boring stuff like that. TV spots of various different names in 10, 20 and 30-second lengths. And then for any given asset, we then have a whole bunch of different languages available, because the idea is these can be distributed to any country and they've got to be fully localized. And so that somebody watching this in Turkey, for example, thinks that that piece of content was made specifically for them. They don't know that it was originally distributed in English, and then people in hundreds of different countries requested a fully localized version of that asset, which is then sent to TV studios, etc. So we've got a huge amount of these different, what we call catalog objects on the platform. I took that snapshot from a dashboard today. So considering there's only 3 main studios on there at the moment, and they're looking to double that by the end of next year, there's a huge amount of data on this platform, and none of it got there by mistake. It's all put there by people. It's all curated, as the buzzword. And so that's a huge amount of information to ingest into a system like that. And so early on in the project, we came up with this system called Slurpy, which is their ingest system. And it handles all of the creation of these catalog objects, so as assets, the 3 different, for any given asset and language, you've got to have 3 different preview files of varying different bit rates. You've got to have the full 10 gig ProRes original version of the file so that it can be downloadable and sent to a TV station, and obviously things like thumbnails and other ancillary small things. And so we wrote this in PHP. It's a command line script. It does really horrible, complicated things like it can extract metadata from the file name, which absolutely horrified us when we first looked at this naming convention, but apparently it's quite standard in Hollywood. They are a strange bunch over there. And so it integrates with the API that we built for the platform to perform the creation of those objects and interrogating, can this thing be uploaded here? Does this asset already exist in this language? And then it uses FFmpeg for all of our video encoding, and then it's putting things into S3 and invalidating CloudFront caches. It's a really complicated piece of machinery, and it's all written in PHP and it's on the command line, which means that it only works in serial, which means if someone dumps 200 files, it's got to go through each one by one, and it's got to do all these operations before it can move on to the next one. And if anything breaks, the whole thing falls over, you have to reboot the service and it starts again from the beginning. So it's a real maintenance nightmare. So it's like, what, 1,400 lines of code. That's just like the core dispatcher of this application. It also has a whole bunch of helper libraries to get there. It's probably the most complicated piece of software that I've ever been involved in building, and it's something I'm not particularly proud of after all this time. It's gone way beyond what we originally intended it to be. And so this is just an idea of this. This is just one aspect of it, is the file name naming convention, and you can see just how complicated it is, that you've got all these different parts that are separated by underscores, and it gets really fun because they're not all necessary. So you have to be contextually aware. So it's not just one big regex, it's several big regexes with context and look aheads and look behinds, and oh my goodness. So we knew that wasn't sustainable. We needed to get away from it, and Slurpee 1 was only usable because it was so complicated, because you had to obey that naming convention. Only administrators could use it, and they understood that if they got it wrong, the whole thing would fall over and they'd have to pay the price for it. So we knew that wouldn't work if we wanted end users of the platform to ingest stuff. So we implemented Slurpee 1.5, which allowed users to drag and drop files into the interface, and that was contextual. So if you dropped something into the Ghostbusters project, then it knew that you wanted to ingest a file for that project. You didn't have to worry about naming the file appropriately. and that used S3 bucket events, and that's quite a nice piece of kit actually. We were really pleased with what we built there. So the idea is there that the user drops a file, the browser quickly makes a call to our API to say, hey, is this user allowed to ingest this thing here? API says yes or no, and as well as saying yes, it then gives an S3 policy document, and then the browser's then allowed to go directly to S3 with that policy document. It says, hey, can I put this file here? Here's the policy, and it's all signed, so it's all tamper-proof, and it means that users can upload files directly to S3. It never even touches our API servers. So, and then we use, once the file is fully uploaded, then we fire off a Lambda function which uses Elastic Transcoder and a whole bunch of other things. And it uses SNS to sort of notify different components about the progress of the operation. And it's quite strict how that's implemented. Users have to upload files of a certain dimension, codec, bitrate, all that sort of thing. And the Lambda function essentially, if any of those criteria are not met, the file gets rejected, because we know that Elastic Transcoder cannot handle encode. It won't encode it properly if it doesn't meet those requirements. So Elastic Transcoder is really nice, but again, you can tell that it's using FFmpeg behind the scenes, and it would be great if you could just put a raw FFmpeg command into Elastic Transcoder, because you know that's what they're doing anyway. That would make our lives a lot easier, because obviously we work with guys that are digital media people. They know things like FFmpeg inside out. It's what all the big studios use. You know, they may use expensive Mac desktop software, but they all use FFmpeg quite a lot as well. So they know all of the various incantations. And we brought that in place to just operate alongside their existing ingest mechanism, just so that we got a way for users to ingest as well, but admins still use the old system. And so what we really wanted to do was get everybody using the same system so that we could completely deprecate and blow away thousands of lines of legacy code that were always causing us headaches. There are so many concessions all over the place because you know that there's this weird edge case for the ingest system. So it'd be nice to get rid of those. So from the client's perspective and from ours, it was a really good thing to do, would be to completely replace all of our existing implementations, get a homogeneous workflow for everybody, keep the really good things that we found works really well in 1.5, which are things like the contextual drag and drop, but also support the legacy mechanism so that a power user, if they know how these things work, can drop 200 files into the bucket or into the UI at once and know that even if you drop them all in the same place, the file naming convention will overrule that if it's adhered to. So all these, so it was catering for end users and real power users as well. And one of the other cool things that we couldn't do before, just because it would have been so complicated, was actually grabbing metadata out of the file itself. So not having to rely on the file name convention to tell what frame rate a file was. You know, we could actually use something like FFprobe to look at the content of the file and figure that sort of stuff out. And of course, because we're now using SWF, well, actually, before we decided we were going to use SWF, these were the requirements. We also needed concurrency and distributed processing. We wanted to be able to, if somebody drops 200 files, for any given one of those files, we want to do all of the sub-processes in parallel. But on top of that, we also want to do it potentially all 200 files at the same time as well and spin up 200 instances in order to achieve that. And so after a lot of evaluating the different alternatives and weighing up the pros and cons as I outlined earlier, we decided upon SWF and implementing everything, having a look at how the current system was implemented, standing back and looking at the orchestration of everything and splitting the problem up into activities and a decider into a flowchart. And also, yes, it gave us the ability where we could now use auto-scaling for handling massive workloads, but a bit more on that towards the end. So obviously, because SWF treats the separation between decision and implementation logic as a first-class sort of fundamental idea, it became really easy for us to split out stuff that was previously like one big 1,000-line function with if statements everywhere. It became really easy for us to split that stuff out. And when you can conceptualize stuff like that a lot more easily, maintenance becomes much easier as well. And also things like long-running activities, things like copying a 10 gigabyte file across a pipe, usually used to make us a little twitchy. We knew that if something fell over somewhere, we're not quite sure what state the application is going to be in after that happens. But with SWF, again, things like long-running activities are considered quite normal, and it allows you to configure timeouts and thresholds and these sorts of things quite nicely through the console interface. And as I was saying before, all of those things that we thought we would have to implement, like message passing, timeouts, etc., we thought we'd have to implement them, but SWF takes care of it. And auditing and logging is done really nicely as well. Again, you can visually see for any given workflow execution, you can see which activities were scheduled, what input data they were passed, what output data they sent, or what error they failed with. And so it's actually something where we've got the confidence now, so we don't have to put logging statements all over our code. We know that if we need to debug something, we can go in quite easily. And also the client is quite confident that they can log in and look at the AWS console and give us a heads up on the sort of triage that we need in order to fix any issues in production. And it also fits quite nicely with our immutable infrastructure strategy, which is again something that Gav's spoken about at length. And that essentially allows us to, I think, and also the previous speaker alluded to the idea with his, I think he named it a Phoenix server, is the idea that we're not patching, whenever a software update is released, we're not patching existing servers. We bring up new ones from scratch with the update baked in, and once those servers are up and operational and they're checked out as healthy, we then do things like switch our load balancer or delegate new work to those new systems. And it fits quite nicely with that because SWF has this built-in idea of versions for activities. So we just upgrade our servers implementations, and then we just reconfigure the tasks in the SWF dashboard to use the latest version. So that's quite nice. We did have a couple of challenges. As I said before, that flow framework is only for Java and Ruby, which we just don't use that in our shop. We built something which got released as an open source library, which I'll talk about right at the end. And yeah, so the other problem was this whole CloudWatch metrics thing, the fact that you can't get a number out of CloudWatch for how many executions are currently in progress, which means you can't tie your auto scaling to that number. So we just wrote a simple little Lambda function which runs, I think it's just it uses the, is it the CloudWatch trigger mechanism where it can execute every minute, and it just quickly spins up, uses the AWS API to figure out how many executions are open, and then writes that number into a custom CloudWatch metric and goes away. So it runs for maybe, I don't know, 50 milliseconds every minute, so it's nice and cheap. And that kind of resolution is probably a little too high, so we can tune that as time goes on. So that solved that problem quite nicely. And also it would be great, we're starting to use CloudFormation quite extensively. That is an incredibly powerful piece of software. Has anyone spoken about CloudFormation here before? Okay, another talk coming up then. That's, yeah, has anyone used something like Terraform? Is anyone using that? Yeah. Yeah, okay, yeah. So essentially Terraform's usefulness is greatly, once one can understand CloudFormation, if CloudFormation supports the things that you use in AWS, the usefulness of something like Terraform becomes greatly minimized. Which is not, it's not because Terraform's bad, it's just CloudFormation is so powerful. But you can't define workflows programmatically in CloudFormation, the templates aren't there. So we still do that one by hand, but we only have to define a workflow 3 times, one per each of our target environments. So it's not that bad and we can get away with that. And the other one that we haven't quite figured out is when we're using auto-scaling, it's very easy to scale out to increase the number of workers. But the problem is when that large batch of work is finished, how do we scale in safely? How do we start decommissioning those servers which we previously scaled out to? If you imagine that you've got maybe 2 tasks that are running, so the auto-scaling system has booted up 2 workers to handle each of those tasks in parallel. One finishes before the other, so that count of workers has now gone back down to 1. How does auto-scaling know which one of those 2 workers to shut down? Because if it's just going to scale out whichever server it brought up last, that one could still be processing and it just dies in the middle of the job. So we're looking at lifecycle hooks to handle that. We probably are going to come up with a solution to that fairly soon, but at the moment we just sort of, the scaling timeout is really, really high at the moment. We wait a really long time before we start scaling back in. It's not quite as efficient, but it does mean that we're much more confident that we're not going to kill a worker that's still processing. Okay, so the final part, just a few words on this little open source library that fell out of our work with Simple Workflow. Really imaginatively titled SWFP, and it allows you to write SWF applications using JavaScript and promises. Why would anybody want to use either of those things? Well, we love TypeScript. It's like our new favourite thing. Perhaps it's just that me and JavaScript have this special communion that a lot of other people don't have, but I thought it still is an excellent language despite all of the bad press that it constantly gets. And TypeScript just adds like a whole nother level of amazingness to that language. So if you're not using TypeScript, especially with TypeScript version 2 that came out recently, a lot of the sort of drudgery and bullshit that used to be associated with the TypeScript project is now mostly done with. It's great. You should really give it a go. And promises are fantastic for writing asynchronous code that's easy to reason about and understand, rather than callback hell. I know we've got things like async and await, but I still prefer promises even with those things. And it does things like, parallel execution, expresses those really nicely, and making sure that errors are propagated or handled in the correct manner is also really easy with promises. And it's what we used to build Slurpy 2, and then once we got a nice little pattern there, we extracted it out into the open source library. And we're hoping that this isn't the last time we use Simple Workflow. We've got lots of other features that we want to add on to Slurpy 2, but also other services that rely on having some kind of mechanism like this to implement. So it will certainly be the power behind those sorts of things as well. If I want to build a decider that uses this library, it's just a case of creating a JavaScript file that exports a function, and you can see there it just uses promise.all to run that first to upper activity and the rest to lower activity in parallel, and then the decision will wait for those two things to finish, and then once they have, it schedules another activity called concatenate with those two parts. So, I mean, if you're not a programmer, if you're not a JavaScript programmer, if you're not familiar with promises, then maybe that all looks quite alien to you. But if you are familiar with those concepts, then hopefully you can see how easy it is to build a completely distributed system that looks like it's all running locally. And you don't have to be concerned with where those activities are running. If one of those workers falls over, if one of the activities fails, you just handle it like you would as if you were making a network call from within your browser. And then if we want to run that decider, the package also comes with a little command line application to run that decider, and it will just poll SWF constantly, looking for work to do and returning decisions, etc. And activities are implemented in much the same way. I've just bunged everything into a single module, and the idea here is that you have a module and it exports a function with the same name as the activity. So here we just have the three activities named first to upper, rest to lower, and concatenate, and you can see there it just gets the first character to uppercase, the rest of the string to lowercase, and it joins two strings together as well. So, and again, same sort of thing, we've got a little command line runner in order to start up a worker that will run those activities as they're needed. So I blasted through that a bit, but I just wanted to cover as much as I could in a relatively short time. So if there are any questions. Okay, yes.
Thank you for that. Very interesting stuff. When you do Slurpee 3...
Hopefully there won't. I did say this on a call the other day, there won't be a Slurpee 3.
And I'm thinking specifically, excuse me, a lot of stuff you've got there looks great, but I'm sort of thinking, could that actually be done using things like Lambda, SNS?
Yeah, that's a really great question. So part of the evaluation that we did before we decided on SWF to achieve this, I mean, this was specific to our requirements. Before I was saying that elastic transcoder isn't great for all purposes. For what we've got, where users are potentially throwing files of any dimension, any bit rate, any codec, and we need to be very certain about what the output's going to look like, and FFmpeg with a very tailored set of commands allows us to achieve that. So we knew that we had to use FFmpeg for this to be viable. And we also knew that Lambda has an upper timeout limit of 5 minutes. So potentially encodes could take longer than that. because of contention ratios and things like that. We can't guarantee how quickly the encoding will complete. And one of the very few shortcomings of Lambda is that there's no real way of knowing when a specific invocation of a function failed. You can get an aggregate count of the number of failures over time, but you can't tell this function was called with this input and it failed after this, or it timed out after 5 minutes. So that's why we knew that we couldn't use Lambda, and it was frustrating because we were hoping that we could just extend what we'd already done with Lambda, but we couldn't. So does that answer your question?
A very quick follow-up.
Yes.
And based on what you said about the way it doesn't sort of integrate well, doesn't play well with the bits of the ecosystem and the poor CLI, do you think it's something that Amazon are committed to maintaining?
Oh, that's a good question. I would hope that it's something where there are potentially enough sort of enterprisey grade people that are using it that they know they can't pull the plug on it. I'd be happy if, you know, I can live with the crummy console and the lack of integrations. I certainly wouldn't want them to pull the plug on it because that really would leave us up shit creek. But you know, I don't know if Amazon have ever pulled the plug on a service once it's gone to the public. If somebody can correct me on that, but they have. Someone's nodding. What was it?
Well, the original VPC implementation got...
Okay, so it got significantly
About, what was it, 6 months after the new one came out.
Okay then. All right. So perhaps they'll rebuild it in some way. I'm hoping that whatever that new implementation is, it's easier enough for us to transition to it. But also, I don't think there's an alternative out there. You've got things like Elastic MQ, but these are all just like message queuing services. There's nothing out there that actually gives you the primitives and gives you the concepts to build a program like this in this way. So yes, fingers crossed they won't yank it. I don't see why they would. I think it will just probably sort of sit there unloved. So if anyone from AWS is watching this, please don't. So does that answer your question? Great. Any other questions? No. Okay. Well, I'll be around afterwards. So if you think of anything, then come find me. If not, you can also send me an email, warren@radify.io, and you can also check out the website as well. We'll be doing a bit of blog posting about all this sort of stuff in the weeks to come. So thank you very much.